All right, y'all. It's about 12:01, and so if other people want to join, there's plenty of time for them to come in and still get plenty of practice, as well as we'll have the session recorded. So let's go ahead and get started. So this workshop is primarily focused on unit conversions, but by the end of it, I think you're going to see that it's an extremely widely applicable math technique, and getting used to using unit conversions and having a kind of a solid way of looking at it, or a method that you find and use, is going to help you a lot in math, a lot in things like quantitative literacy, or in your day-to-day life. It comes up very often. As we'll see later on, prices like gas per gallon is a unit conversion, or it's a unit factor. Um, and so it's very helpful for everybody. And then as you get into especially sciences, depending on what your goals are, it's an important skill to have a firm grasp on. So what I want to start with is just a quick outline. And this shows you all the things that we're going to try and touch on. And I don't want that to be daunting. What I want it to be is encouraging, because you can see how much um, unit conversions affect in your day-to-day life and the lives of things going on around you. Um, Most likely, whether you realize it or not, today, either already or at some point today, you will think about something that may require a unit conversion. So it's important to start recognizing them as best you can, and to understand how to apply them. Uh, in an organized way is going to be best. So the first question is, what are units and why are they needed? So numbers, numerical values themselves, and don't let this get too highbrow, we're going to break it down, but just numbers come in basically three different types. And those three types are the listed here. It's categorical. We use phone numbers to categorize information, like phone numbers, zip codes, social security numbers. The Dewey Decimal System is a categorical number system. We're not using math with these numbers. We don't manipulate them in the same way that we do with numbers in algebra. So the example I have here is, if you add two phone numbers together, it doesn't help you in any way. It's not even going to get you a phone number you can use, right? So the second value, not category, well, I guess category, but I hate saying that because it's categorical is the first one. But the second grouping of numerical values is counts. And these are concrete, I like using this idea, concrete, solid objects. I can count my fingers. I can count the number of people in a room, the number of ice cubes in a tray, the number of eggs that my chickens lay. We have concrete understanding of what this represents, right? One finger, two finger, three finger. That's a count. And so that's the more understood use of numbers, and we can manipulate those numbers in order to show what we need to with counts, essentially. And then lastly, we get into something called measurements. And measurements is going to be things like inches, seconds, grams. It's indicators of physical or abstract concepts that we as a people who communicate with other people have to be able to say things and communicate these values with some understanding of finality. If I'm a carpenter and you're a carpenter, and I'm building one side of a set of stairs just to whatever the way I think it should go, and you are using whatever the way you think it should go, and let's say we're using our fingers instead of a measurement to measure out, like, okay, I'm going to cut this board 5 fingers. Well, if your fingers are smaller than my fingers, we don't have a standard unit, and that bridge is going to look pretty wonky, right? So we need units to be able to communicate with one another in a society, so that we have a solid idea of something which may be abstract. The idea of an inch is really an abstract idea. We just apply it to things in order to make it a measurement. So once again, I know that might sound wild or a little bit highbrow or whatever, but you use these already day to day, and I think you'll get more comfortable with this as we move further into this discussion. So the concept of one, and I kind of touched on this, the concept of one is, what do we concept, or how do we define what is one when we're measuring? What is 1 inch? What is 1 foot? What is one, etc.? Well, in the past, they used things like the length of a king's arm or foot. I think that the measure from the elbow to the wrist was commonly used in building based off of a single king. And so you would have them measure a string for this king or whatever at some point in time, and then use that and try and transmit this idea throughout the kingdom. Well, what happens when that king dies, or he grows, or he loses an arm in battle and you don't have enough string to keep on measuring and figuring it out? We have to have a standard idea of what we're talking about in order for you and I and anybody we're talking to understand the distance or the measure that we're talking about. And so this is where we come into a standardized arbitrary measurement to count as one. Like 1 foot is 1 foot everywhere because it has to be. And that is the concept of a unit. Okay, so we'll get out of more of the talking. We'll get into some of the math here soon. So let me first introduce you to the U.S. system of measurements. So the U.S. system of measurements, you all should be pretty familiar with. It involves things like distance is measured in inches, foot or feet, yards, miles, commonly. We measure weight using ounce for small items, and more often pound for larger. And we use, when we're talking about volume, so volume is the amount of space filled. We use teaspoon, tablespoon, fluid ounce, which we'll get into a little bit in the conversion later when we talk about gallon man. Fluid ounce is important for us, and 8 fluid ounces is actually in a cup, and that's one of the conversions we'll talk about. And then the gallon man comprises gallon, quart, pint, and cup to help you remember some of that. So, and temperature commonly, especially in America, in the U.S. system, we really just use Fahrenheit. And the best way to think about Fahrenheit when you're talking about temperatures, because we're going to learn 2 others today, Fahrenheit is temperature as it relates to human beings' experience of temperature. Because you'll find when we convert to Celsius, Celsius is not as easy to explain the temperature as it relates to you or I, but we use Fahrenheit because it's really easy for me to say it's 50 degrees out today, so I could really use a light jacket, or it's 90 degrees out today, and that tells me exactly a pretty finite range that I understand through my own experience, while things like Celsius and Kelvin relate to the metric system, and Celsius relates to water. But we'll continue. I hope I'm not giving too much information too early. And if anybody needs me to slow down or has a quick question about a concept, please feel free to chime in. So let's move. This is just to introduce you to the U.S. system of measurements, the common measures that we use. So let's get into what you're here for, which is the basics of actual unit conversion. So suppose we want to convert 5 feet into inches. We know that there are 12 inches in 1 foot. That's a conversion factor, right? We get that by looking at a ruler, which is standard. And so those measurements are standard anywhere. So when we get this answer, we know it's the same answer here as it is on the other side of the world, as long as we're talking about feet and inches, okay? So knowing that there are 12 inches in a foot, we form the statement that 12 inches equals 1 foot. That can create two conversion factors. They're equivalent, but it really depends on what we're going to want to use as to choose which one we do use. But the conversion factor that are equivalent is 12 inches over 1 foot and 1 foot over 12 inches. And you see here my definition that a conversion factor is a fraction with equivalent statements on the top and bottom. Because 12 inches is equal to 1 foot, this is equivalent. And because 1 foot is equal to 12 inches, that's equivalent. So if we want to convert 5 feet to inches, then, and forgive my drawing here, we would say 5 feet is what we have, right? Over 1, because anything over 1 is itself, times, and we would need to select a conversion factor that's going to give us inches. And you'll see this as a common theme as we're moving forward, that what I have to start is going to be in the top of the numerator here, feet, and what I want is going to be in the top of the numerator of my conversion factor, meaning inches needs to be on top here. And so what we get is 5 feet times 12 inches is going to equal 60 inches, right? Oh man, that is ugly. My other ones, I think I actually had time to put in like the typing, so you won't have to look at my scribble this entire time. I promise, I promise. But I just wanted to show that's a real quick conversion factor. So the idea is we have what we have on the top of the numerator of the starting fraction, and then what we want in the numerator of the conversion factor, because this is over 1 feet too. And so they cancel out, and we're left with our answer. So let's get to a kind of a cleaner example. Oh, I did set this up. Okay, so perfectly. So we'll go back and let's set it up a little bit cleaner. So we have 5 feet as our original value. As this is a whole number, it needs to be placed over a 1 to form a fraction. So you can always be multiplying fractions here, and I will continue to do that because it's going to become easier as we go forward to always be multiplying fraction times fraction times fraction times fraction. It just makes it easier to see. But as we multiply 5 feet times 12 inches, you can see that these are always, the diagonal units are always going to cross out, and we want them to, because the unit we want is inches, right? So as we multiply across here, 5 times 12 is going to equal 60, just like we had said. So that's the common way you want to set this up, is you want to make sure that what you have is in the denominator, excuse me, in the numerator of the starting fraction, and just place it over 1. And then what you want is in the numerator of the next fraction. So let's keep on moving forward. As you get into conversion factors, you're going to want to look one of these up too. This is a conversion factor chart. I'm going to show you some common ones later on that you'll use more often, and some that you may end up needing to at some point memorize. Like 1 yard is 3 feet. It's commonly used. Stuff like that. 12 inches in a foot. Most of you probably know that. 5,280 feet in a mile is sometimes given in problems. So you might want to try and remember those, but most of the time you're going to want something like this in order to give you the factors that you need, because a lot of them, especially if you look here at the American to metric units, metric is a very different system, and I'll start to explain that, but we don't convert very nicely. 1 inch to 2.54 centimeters, 1 foot to 0.305 meters, 1 yard is like just over a meter. So 1 mile, 1.609 kilometers. And you will need to do US to metric conversion, so it's important to note that. But metric converts well within metric, and American converts kind of well within American. Honestly, it's not that great, but American to metric is kind of a mess. So you'll need a conversion factor chart for most of that. So, and in the scientific community, you'll use a lot of metric because I don't know, Americans just don't really have their stuff together when it comes to scientific measurements. So, and here is, I think my next slide is, yes, here's actually a common handout that we have in the Learning Lab. And if you're coming in and you're working on metric stuff, then just ask one of us to try and find this in one of our little hideaway places. But we have things like this as resources for students if they need them. And I think it gives you a good amount of the metric conversions that you need. And I had some highlighting on here for ones that I thought was also important. But really, length you see a lot of, area on occasion, speed on occasion, volume, especially US volume, we're going to talk about through the gallon man. I don't like this Celsius to Fahrenheit conversion. I'm going to show you an easier way to convert that mathematically. But weight is a great one to try and understand, because once again, you know, grams and pounds and kilograms don't always play together well. So you really are often not going to be expected to memorize these conversion factors, but what you need to do is be able to apply them. And that's really the key, right? So let's move more into kind of the real work of it. So using our conversion factor, let's find out how many inches are in 14 feet. So we set up our conversion factor here. We have 14 feet over 1, because over 1, anything over 1 is itself. It just makes it cleaner, and that's why I do this. And it makes it easier to see that I'm crossing this out and I'm crossing this out, so I can be left with this, right? But I encourage you, as you're setting your conversion factors up, to try and do that, just to make it easier. And as I get into the train track method, that'll become even more clear. Excuse me, take a sip. So as you can see, we're going to just multiply. And the lovely thing about fractions is when you are multiplying, which is what you're going to be doing for conversion factors most of the time, is you multiply just across both lines, top and bottom. I multiply across the top line and I multiply across the bottom line. And so what I end up with is really 168 over 1. But anything over 1 is just itself, right? So I get left with just 168 with feet crossed out and my new unit, which is inches. So I'm hoping this is starting to show a pattern of how these are going to try and go. This diagonal crossing out, right? And then just multiplying across. And I'll throw a few wrenches in the gears here soon, but I really want you to see that, because the core of this is method. You can apply this to a lot of things, not just inches and miles and metric system, and we're going to get into that. So let's continue with some more US to US examples. So if I have 72 inches and I want to figure out how many yards that is, I'm going to need to use a yard to inch conversion factor, right? If I look back at my conversion factor sheet, I can see that 1 yard is equal to 3 feet, or I'm going to go ahead and make 3 feet 36 inches, because 12 times 3 is 36. So when we multiply across here, and you might have already seen the math we do here, I'm leaving a step out. And that step is 72 times 1 is 72. And 1 times 36 is 36. So this 2 yards comes from 72 over 36. And on occasion, you're going to get conversion factors where the number in the denominator of your conversion factor is larger than the numerator, as it is here. And what that will end up being is a division problem, right? That fraction needs to be divided. But doing so is just going to shrink that number to the unit it needs to be. And this is how you can convert something like a large number of a small unit into a small number of a large unit. That's a tongue twister, right? So I wanted to show you that before we do this little word problem. So you have a project which requires 108 inches of cloth, but the store only sells it for $15 per yard. So, okay, well, how am I going to figure out what I need to pay in order to get all the cloth I need for my project? Even if it's extra, I have to know, right? So you would find a conversion factor for yards, or excuse me, inches to yards, right, which we have here. And if you set up 108 inches over 1, like we've been doing, and you said, okay, I know that I'm going to get rid of inches, so I put inches on the bottom, and I want yards. I end up with 108 over 36, which equals 3 yards, right? Now I know, okay, payment is also, if it's $15 per 36 inches of cloth or per yard of cloth, that is a conversion factor just like any other. And so once again, you may not even realize it, but if you bought gas today, you bought a candy bar today, you went, you participated in commerce in any way, you had to deal with some level of the conversion factor. Getting 6 yogurts for $3.25 is a conversion factor. And starting to understand those, you can start to manipulate, well, how much am I getting per yogurt, et cetera, et cetera, et cetera. Those are conversion factors. So, okay, continuing with this, let's do some kind of stretches. I'm gonna start showing you some multi-step, and then we're gonna reel it back a little bit, and then I'm gonna give you kind of a better form to kind of take on these multi-step conversions. So let's take the conversion factor of a mile and the one we just had, which was feet and inches, right? So if you know that 1 mile is equal to 5,280 feet, so what if you wanted to know how many miles 2,000 inches is? It's an odd question. I don't really understand when you would be asked it, but I want you to be able to feel I think it's kind of cool to be able to find stuff out like this, because even if you would have never asked yourself, it's kind of an odd and interesting thing to know, right? So you would set up your conversion factor to have 2,000 inches over feet, right? Knowing that crossing out inches is going to get you your foot amount. So that ends up being 2,000 divided by 12, right? Then that number needs to be divided by, because you have feet now, so that's going to have to cross out. That's going to have to cross out in order to get miles. You'll have to divide by 5,280. And so what you're left with is 0.0316 miles. Not very far, obviously, and you really wouldn't expect it to be. But you can convert things like inches into miles if you want to. And as you get into more of science classes, some of these conversions will get either extremely large or extremely small, and that's where things like scientific notation is going to become prevalent. And I'll show you scientific notation near the end of this with a quick blurb about Avogadro's number, but I don't want to go too far into that. We actually have another conversion factor workshop which focuses more on chemistry and real-world applications in that regard. So I just kind of want to give a little sprinkling on top at the end so you can see, because it's pretty interesting. So how about the opposite of this? And I'm going to skip this over. How about how many feet are in 3.7 miles? So if I'm going to run 3.7 miles, how many feet did I run that day? And the answer is, if you set up, this is a simple conversion because it's just back to multiplying back across, right? But I cross out my miles. Oh, here we go. I cross out my miles. Let me change that color. Cross out my miles, right? These are going to cross out. And I'm left with feet. So 3.7 times 5,280 is going to be 19,536. So a lot of little questions, and I know I just threw a lot at you real quick. So I want everybody to take a quick breath, stretch in your chair for a sec. All right, and grab a drink of water. Okay. So what more can we do with this? Or actually, let me solidify this rule for you. I've been crossing out, the units that we're leaving behind in favor of circling the units that we're getting. And I want you to try and remember when you're converting what you want, and this is for the conversion factor that you're using. What you want is pretty much always going to be on top. There's a few scenarios where you might be starting with a conversion factor where what you have is in the denominator, and so this is going to switch. But as long as what you have is in the numerator of the first fraction, when you're talking about the conversion factor, remember what you want to get is going to be on the top of it. And what you have, what you're trying to convert away from, like what this has, needs to be in the denominator of the conversion factor, right? So that these can cross out. Because when you multiply anything over, essentially it just crosses itself out anyway. If you take even this to its logical conclusion, it's WH over H. Anything over itself is just 1, right? So in order to be left with W, that's the process that you always want to remember. And I hope that kind of diagonal step is clear, because that's not math. That's just seeing a pattern. And I want pattern recognition to be the height, because trust me, I'm not a math guy. I learned this stuff by finding the patterns. So later conversions are going to contain, and you've already seen some 2 or 3 steps, but I'm going to show you some longer ones, and these conversions can contain a multi-step process. Keep calm, follow your rules and your conversion factors for success. A lot of these problems can look really super daunting, but it's always about breaking it down step by step by step by step. Make yourself a map of where you need to go, and then get there using, we use train track method or whatever you feel most comfortable with. So let's continue getting some practice, keep getting comfortable with this, and then we're going to start showing some more multi-step problems, okay? So US weight and measurements, I wanted to go over 1 or 2 things, and I'm a biology major first, so when they ask me to do math stuff, I want to add in cool little animal facts where I can. So Let's think about 1 ton. And 1 ton is, unless you're talking about a metric ton, but 1 ton is, metric ton's completely different. We'll talk about it later because we have to be different apparently. But 1 ton is equal to 2,000 pounds. Therefore, we have our conversion factor. So the African bush elephant, the largest land mammal in the world, I believe there are whales that are much larger. I could be wrong. Someone can call out if I am. But the largest land mammal in the world is the African bush elephant, and it can reach weights of around 13,000 pounds. How many tons does that animal weigh? And if we do the math on that, quick little conversion, 13,000 pounds times tons divided by 2,000 pounds, so the pounds is going to go away, it equals 6.5 tons. I don't know which number is more impressive to me, honestly, but I guess 13,000 pounds, just because I have a better understanding of what a pound is. I mean, I can lift a 30-pound weight, but 13,000 is extremely big. And those are creatures that live, in our world. So understanding something about them, even as a biologist, no matter what you're doing, this stuff has application, and that's part of what I want to highlight with some of these problems. So, all right, here's another little thing. So I'm going to say a word colloquially. It means like how people speak. So you may use even a conversion factor that is used in another country as like an odd thing. So if you ever go to, and I don't know how much, I've never been to the United Kingdom or London or anything, but I have heard from movies or whatever, as well as conversion factor sheets, that there's still this idea that for them, 14 pounds is equivalent to a stone. And I don't know what stone from where once weighed 14 pounds, but it's common for them, for the English to refer to weight, especially if you're talking about just casually how much you might weigh or a person might weigh or something. Casual weight measurements can often be referred to as stone, just so you have a quick understanding across that culture. And so we get a conversion factor from this, which is 1 stone for 14 pounds, right? The equivalent statement. So if Jerry is traveling in America, I don't really know Jerry. Let's say he's an ex football, and I don't mean football, I mean a football player. He's kind of a big guy. Was asked by a local, "Oh man, about how many stone are you?" What should Jerry say if he weighs about 182 pounds? Pretty big guy. So that 1 stone, 14 pounds is still the conversion factor. And you would still just set it up as we have. Pounds, what I have over here, what I have, and I'm getting rid of it in the denominator, and then what I want on top. And so he can say, I weigh about 13 stone, give or take, if you do the math. So, because 182 divided by 14 is 13. So, once again, this stuff comes up everywhere, every how, every way. Sometimes it's not even considered math. So, let's see what the next thing is. Oh, good. Okay. So I'm going to get on my soapbox for a second. This is one of my favorite things to talk about. U.S. measurements are unusual, and they're unusually difficult. And I don't know why they are the way they are. I should probably do some research myself into the history of the U.S. system of measurements. But the metric system, which is used throughout the world, and is commonly used in most scientific usage. I won't say all, because there's still ecological and biological stuff that happens in America, as well as others, where it's just easier sometimes to use U.S. Measurements. But it is the commonly accepted, metric system is the commonly accepted international way of measuring things. So if you go to another country, you're going to be talking about kilometers per hour. rather than miles per hour, and so on and so forth. So let's introduce you to the metric system. Part of what makes it so easy is it works on a power of 10 scale. So this means that when you move up and down, all you do is shift a decimal point, because our number system is based off of what's called base 10. It means that you go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in the ones place, and as soon as you hit 10, you gain another place, right? That's why 10, that's why 10 looks like this. So if you're trying to move to a smaller category, like if I wanted to have 10 grams, and I want to know how many milligrams that is, I just shift the decimal, the number of steps on the metric scale, to that. And I've got some better examples that I'm going to show soon, but let's see here. Oh, I lost my side panel. Just stay with me here. So when you're talking about metrics, distance is referred to usually in meter for close, kilometer, or centimeter. Weight is, especially in chemistry and things like that, is gram. Like I said earlier, the metric ton is different from what we call the ton, or the short ton. A metric ton is actually equal to 1,000 kilograms. So they even have their own ton. Volume is usually in liters. If you're in a lab, it's going to be milliliters. Try not to forget the big L. That's always important. And then temperature is, in the metric system, is often used in the scale of Celsius and Kelvin. And that's not to say that you don't hear temperature for weather or things like that described as Fahrenheit still, because that relates to people. But Celsius especially is a system that is based off of not how we feel things, but it's actually based off of how water feels things. So 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point. Conversely, Fahrenheit, which is really just to appease us and our ability to speak to each other about temperature, freezing point is 32 degrees, right? And boiling point of water is something like 212.3 degrees Fahrenheit. So when you're in a lab or you're working with aqueous solutions, or Kelvin will come into gas law, but Celsius and Kelvin both identify with the metric system because of their use in quality measurements. Celsius because of its relationship to water specifically. So that's important to just remember as a side note as you move forward. So Fahrenheit is about people, Celsius is about water, and I just think of Kelvin as about gas because that's most of how I use it, but it's used in some other scientific understanding too. So I think we hadn't gotten to this yet. Not good. Okay. So when I was saying that the metric system is a base 10 system, I think this is the best way to visualize what base 10 means. And that means if you look here, here are the ones that you're probably most familiar with. Is you have kilometer, hectometer, which you use, decameter, base, decimeter, centimeter, and millimeter. And it might be kind of hard to see that right there. I have grams, liters, and meters written because base is really those three things, right? Base represents those units. Gram, liter, and meter are considered the base unit of the metric system in which they inhabit. So as you go up, you can see that 1 gram constitutes 1,000, or excuse me, 1 kilogram constitutes 1,000 grams because it's 1, 2, 3 steps. That's 3 zeros added in each place, right? Or conversely, if you're going down, as you become more and more minuscule, you can see the pattern of how these numbers increase in their space, and that denominator becoming larger means that number is becoming increasingly small. So this is the reason why we use scientific notation in a lot of chemistry, is because you start working with numbers and concentrations down in the micro and the nano and the pico. Or if you're talking about atom concentrations, I'm going to show you one here in a bit, and I want you to remember what septillion is. Septillion is something that has been raised 10 to the 24 times. That's 10 times itself 24 times. That is a massive number, as you can see. And I've got a problem we're going to show you. I'm going to show you how you can get this number just doing regular conversion math. So don't be daunted. And once again, this is a picture of a sheet that we do have in the Learning Lab. We encourage y'all to come in, take advantage of the resources that we have. We love helping y'all out and helping break down some of these odder concepts. But so let's look real closely at the one I have, the kind of the bracketed area here that I'm going to finish this circle on. So you should have heard about this area before. Kilo, hecto, deca, base, deci, centi, milli. These are the most common of the metric system conversions. And working through them requires a little bit of work. You can use the page I just showed you, this page, and if you use it, you can use these values in order to determine where you're going from base or etc. But there's a way easier way to convert metric values, especially within that KHD B DCM. Okay, so that's only 7, but I want you to start by remembering this, and this is called a mnemonic device. The M is kind of silent, but it's called King Henry died by is important, drinking chocolate milk. Those letters should look familiar because you just saw them on the other page, representing kilo, hecto, deca. You will occasionally see deca with a K. I've seen that a couple times recently. It confuses me. I don't like it. It's not the way I learned it, but it can happen, so just be aware. But king is kilo, Henry is hecto, died is deca, by is base, which remember is gram or liter or meter. Deci is drinking, chocolate is centi, and milk is milli. So King Henry died by drinking chocolate milk. Sucks for him. So we can use this simple phrase to move our values, whatever value or measurement, along the metric line. About 15 minutes left. So I might have to pick up the pace on some of these, so we'll make sure it's clear though. How many centimeters are in 8 meters? So meters we know is at base, so it sits in the middle. I said M, but this is because I used to put M there. Imagine that says B. So we're right here at B, right? Centimeters are 2 spaces down to the right. So all we're going to do is we're going to make a motion where we say, okay, if I am here at meters, because base is meters, and I need to get to centimeters, go 1, 2. All right, I've made those steps. Now, I'm going to come down here to the value, the measure that I want to convert, and I'm going to do the same thing. I'm going to start at the decimal place, and I'm going to go 1, 2. And what happens is, and I hope this is clear, is that you keep this 0, and all you're doing is you're moving that decimal place to right here, right? You're changing the value, or excuse me, the unit to the unit you're looking for because it's accurate, right? And anywhere, like here, we didn't really have enough space. Anywhere that you have a gap, you just add in a 0. That's it. So you didn't do any math, and you have converted 8 meters to 800 centimeters. So let's see a couple more, because this is a quick trick that you can use, and it's like no math, all just moving. I mean, I take my pencil, I go and every time for me. And I'm sure there are smarter ways to do this, and there's people who are better at math than I am to do it, but I'm the type of guy who still sings the alphabet song to understand, the letters in my head. So for me, I keep it simple. And this is the simplest way that I know how. And I think there's no shame in keeping it as simple as possible. So when we're continuing on these metric conversions, let's try this. So if I'm going to go from centimeters, so let's go back to meters, right? If I'm at centimeters, I need to take 2 steps to the left. So I take 2 steps to the left. And those steps are a little ugly, sorry, but you can see that just ends up putting my decimal place right in front of the 3, and I can read this back as exactly what it is, which is 0.3 meters. And then for this next one, so if I want to go from centimeters to millimeters, 1 step to the right, 1 step to the right is just 1 step to the right. All we have to do is move that over, and we have our new value. And you can go from kilometers to meters, or kilometers. You can go all the way to millimeters. It's just going to be a really big number. But it's 3 steps. Here, let me clear that. It's 1, 2, 3 steps to meters from here. So 1, 2, 3. There we go. Left with 25,800 meters, 3 steps to the right. So use that, the King Henry method, the King Henry died by drinking chocolate milk method, for any of those quick unit conversions, because it's going to be much easier than trying to look at something like this, figure out the difference, do all of that. And that's just me personally where I get to with it. So all right, we had US, we had metric, let's combine them. So what about converting from the US system into the metric system? So I'm going to give you kind of a speed problem, and I don't want to confuse you, but in this case, the 1 here is actually, it's important, right? But it's not going to be lost, and I'm going to show you how. So if we're driving 65 miles per hour down the highway, wherever, but would like to know how fast that is if we were driving in a European country, then we would need to use the conversion factor. 1.609 kilometers is equal to 1 mile. We set it up so our miles is on top, right? And whenever you hear 65 miles per hour, that per indicates where you want to put the separating fraction line, and that's going to put 1 hour in our denominator. But look what happens here. We may cross out miles, right? Because they're going to multiply over, right? And then miles is going to be over miles as a unit, so it cancels out. Kilometers we're going to be left with, but there's nothing to, I'm not sure where that came from. Kilometers is something we're left with, but so is hours, right? Because hours doesn't get canceled out. It has nothing. This is not kilometer hours up here. This is just kilometers. And so our answer here in this US to metric conversion is going to end up with both kilometers and hours in the answer. And it makes sense because we're talking about a speed. We wouldn't have gone from going 65 miles an hour to a distance of 104. That would make 0 sense, right? So make sure we're thinking about what the question is asking and what makes sense along the physical terms of it. Because like I said, the thing about conversion factors is so much of it happens in day-to-day life. So let's quickly get through this next one. So if we wanted to know how many ounces are in 35 grams, 35 grams times this conversion factor. So you're starting to see the gist here. Boom. We're left with ounces. That's what we want. Okay. So next up, here's just a couple commonly used US to metric conversion factors. If you have to use them or remember a few, these are helpful, but if you have just a good conversion factor chart, most of the times when you're going to be asking these questions, you're going to be given those. It's not common for you to have to memorize these. The point of all of this is really understanding the method. So where am I at? Yeah, let's get into, this is very basic US to metric practice. We're running short on time. I'm just going to run through it really quickly. You can see if I'm setting up feet and I want to know meters, I'm using one of those I just showed you, which was 0.305 meters to 1 foot. It's going to be 230.58 meters. And then how many centimeters are in 327 inches? Well, because centimeters are 2.5, it's going to be roughly, 2.5 times the amount of inches. So we end up with that. And I'm embarrassed because I'm a scientist and I left off units here. If I was grading something, I would take points off if I ever left off units. So just a note on that. Okay. Let's introduce you to rate and time real quick because I want to show you train track based off that. It's the easiest way to think about it. So here's a 3-step conversion problem, right? Time may also be converted using conversion factors. If you start with 24 hours in a day and you wanted to figure out how many seconds in a day, you would have to set it up step by step to where the conversion factor would have hours on top here, hours there. But then once I have minutes, the next factor I need has to have minutes on the next. You can then just multiply across both the top and bottom. In this case, 1 times 1 times 1 is just 1. So you're left with 86,400 seconds over 1. But as long as you set it up this way, you can just multiply across the top and multiply across the bottom and solve for what's left. So that's a simple way of figuring out the amount of seconds in a day, right? Okay. Let's talk trains, all right? We've all seen trains before. I hope we've all seen trains before. At least we understand what a train is. Train tracks have, that kind of bracketed set. And so we're going to set up our problems looking kind of like a train track, where these areas are implied multiplication signs, right? Oh, that's an ugly one. We organize this based off of whatever unit, like unit here, and let's say it was like unit for A here, so it was A here, and then it would have to be B here, so it would have to be B here, in order to get what we're looking for, which would be, I guess, C, right? So we have been seeing conversions that are just 1 or 2-step problems. We can have much more complicated conversions. So time, for instance, takes multiple steps to convert from, say, seconds to years or vice versa. So what do we do when we have a long way to go? What we do is this. First, we make a map, and I am Dora the Explorer when it comes to making maps. I need my map buddy to help me because I need that visualization in order to show me where I'm going, right? And so if I was going to say I want to convert 9 million seconds, huge number, into how many years is that? What conversions would I need? Well, I know, first off, I have seconds, so I need to get to minutes, right? Okay. If I have minutes, then I'm going to need to get to hours. So that's this here and then this here. And if I have hours, now I'm going to need to get to days. And then if I'm going to have days, I'm going to need to get to weeks. And then if I have weeks, I'll need to get to years. And conceivably, I can find the conversion factors for each of those, but I'm going to need one from here, from here, from here, from here, and from here. And there's no shame in not putting the math down until you know where you're going. It's like, trying to do the math on a multi-step conversion factor problem is like starting to dig for, treasure on a desert island without ever looking for an X or a map or just asking advice. So give yourself some visual representation to follow, and it'll make it, a much less stressful enterprise. It might take you 2 more seconds to write it down, and it'll be worth the brain cells you save, trust me. Okay, so now that I have my path, so to speak, I can lay out my train track, right? I'm going to just chug along my train track based off this path, and I don't have to keep on whacking my way through the trail at every step. So I set it up in a way that's similar to this, right? And remember, we have implied multiplication signs at each of these intersections. So it's really just 9 million seconds over 1 times 1 over 60 times 1 over 60 times 1 over 24 times 1 over 7 times 1 over 52. And as you go, you see it has the pattern, and we have to check our patterns here, that this crosses out with this, or excuse me, this crosses out with this crosses out with this crosses out with this crosses out with this. And as long as I have the correct conversion factors, and I think I do, and there's other ways you can do this problem, but I wanted to stretch it out as I could to this. But as long as I have accurate conversion factors, then my answer is going to be accurate, right? Whether I multiply all of the bottom row across and all of the top row across, except for my answer here, and then just divide after, or if I go step by step and divide, 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 it doesn't matter. As long as I've set it up properly, I will get the right answer. And so that's what I mean when I'm saying the method to this is the key. This will end all the madness of it. I promise. Just taking the time to give yourself the map to your answer is going to be so helpful. Okay. So let's see what we have left here. We're getting low on time, but I want to talk real quick about temperature conversion, maybe money, and some area and volume. We may not have time to get into moles and molar mass, but we can use that. There's another conversion workshop coming later on. So on April 14th, actually, if you want to put that down. But if we're working at temperature, it's slightly different. Temperature conversions are really just algebraically found. You have a conversion equation for Celsius, a conversion equation for Fahrenheit, and a conversion equation for Kelvin. Fahrenheit to Celsius, so if you're trying to find Celsius, right, and if I have 70 degrees Fahrenheit, right, then I would place that 70 into where Fahrenheit is, just like I have here. And you end up subtracting 32, dividing by 1.8, and that is going to equal 21.1 degrees Celsius. So you can see how it's way easier to tell somebody that 70 degrees outside than 21.1 degrees Celsius. Conversely, if you want to convert Celsius to Fahrenheit, Fahrenheit is equal to 1.8 times a Celsius amount plus 32. And this actually does need to be in parentheses. So you would have 20 degrees placed here times 1.8 plus 32 is going to end up getting you 68 degrees Fahrenheit. So you can see they're pretty similar, 20 degrees Celsius and 21 degrees Celsius, and they should be. And then this is one of my favorite conversions, Kelvin conversion. Just add 273.5 to Celsius, or 15 to Celsius. That's it. That is all. That is all you do. You find Celsius, you add that number to it. Some scientists, depending on what you're doing, they even ignore the 0.15. That's it. Money conversion, we all love the idea of eventually being able to go to another country. So let's just remember that between when you travel to a different country, foreign exchange is going to affect the amount of what your money is worth. I made this a couple weeks ago, so this conversion rate may not be accurate, but if we use, our conversion rate here, if we're going to a trip or on vacation to Paris, we're bringing $200, which, as I understand it, that is way too little money to bring to Paris to spend. How much will we have in euros? So we simply set up our conversion factor to where dollars will cancel. And here you just have to see that dollars is the sign. We're looking for euros here. And we end up with 167.39 euros. So I'm going slightly over. Give me 1 or 2 more minutes. I really want to talk about area volume, and we'll just do a quick review. So area and volume, I want you to try and look at this guy. This is my buddy. His name is Mr. Gallon Man, and he gives us these very quick conversions of US volume, which is super helpful in the kitchen and just understanding quick volume amounts. But you can see that in Mr. Gallon, the big G, there's 4 Q's. Those Q's represent quarts, right? So for every quart, he has 2 pints, those little P's, like a pint glass, of milk, of course, or soda. And within each pint is 2 cups. And then I added this, a cup in the US has 8 fluid ounces in it. So 2 cups is also 16 ounces. Fluid ounces, and 16 ounces is a pound. So it's helpful to remember some of these. Gallon Man helps with volume. It's another mnemonic device to help you see that and be able to get pretty much all of these pretty quickly if you need them on the fly. I think I had some problems to try and show you that, but I don't want to keep you too long, so let's just do a quick review of what we did talk about today. So let's remember, we learned about how to set up conversion factors and how to plan our problems, and that's a key, okay? We learned some key conversions in both the US and metric systems, as well as conversions across them. We learned about temperature conversions, Fahrenheit and Celsius, and I even tossed in Kelvin for those of you who are going to be doing science more often than others. We got all aboard on the train track method, and we learned how once we have our plan, if you set it up like that, you can really just chugga along. You know what I mean? And then we learned about how much our money would be worth in a foreign country. Unfortunately, only one. I always want to do more examples of that because I think it's fun, but it's also kind of sad during COVID because I don't know the next time I'm getting to Europe, if ever. Excuse me. We did some multi-step time conversion problems, and that was really where we showed how many steps you can have in some of these unit conversion problems. So be proud of yourself. That's a lot of math, and that's a lot of things to set up and to hold and to think in your head at once, and to be able to get a successful result with. And we met my buddy the Gallon Man. We learned about US volume and conversion factors. And I'm really sorry that we didn't get to talk about some chemistry conversions, and learned about Avogadro's number. But really, thank you for sticking with me. I really hope this will help. And please come if you have any more questions, April 14th to the math, chemistry, and real-world applications conversion factor thing. I'll have a lot more on Avogadro's. We'll be doing a little bit of stoichiometry work just in seeing how that relationship is. It gets really exciting because you start to see how scientists will be able to determine yield of a product from just a chemical equation, and that's very interesting and very helpful stuff. So, but thank you everybody for attending. I really hope you enjoyed it. Have a wonderful day. I think that's it. Are there any questions before I do leave? I'm happy to sit and take any that y'all might have. I think there's a chat function where you can just blurt it out. All right, speak now or forever hold your peace. All right, everybody, have a wonderful afternoon.
Thanks, Ellen.